Okay, so we were asked to take this polar form, which is in the form of r e to the I theta, and translate it to the regular complex form. And now you're going to see, remember, this is radians. This is radian measures, so we're going to have to be careful. Let's just do it. So I'm going to go and make sure I'm in radians. 4 radians cosine is like minus 0.65 and change or whatever times 2. So this is this bit, 2 times cosine 4 is minus 1.307287242, blah, 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 plus I times, and so here the I is going to go at the end of this, and I'll show you why in a second. And this, don't freak by this. I sine theta or sine theta I, it's just typical that you put the I in front of cosine or sine. It's typical to put I in front of trigonometric functions or square roots. Pretty much the only time you leave I behind is like 3 plus 5I. It's not that big a deal, but it does disturb people. Remember, in complex numbers, just like real numbers, A times B equals B times A, so 5I is the same as I5. It's just a matter of a notational standard. Well, what is 2 times sine 4? 4 sine, and notice I'm in radians, times 2. This is minus 1.513604991. Still what's going on. Where should you approximate these? It really depends who you're working for and what you're doing. I would say that this is pretty close to minus 1.31 minus 1.51I. This is, or plus minus 1.51I. This is a reasonable approximation. Okay. Oh, there we go. Here's some good stuff. So we're going to multiply some numbers, some complex numbers in polar form, and see what we got here. What is cosine pi over 2 plus I sine pi over 2 times cosine pi, parentheses in there, plus I sine pi. Well, okay, so in theory, we should be able to do what? Remember, if we have this, z is equal to r1 e to the I theta 1, and w is equal to r2 e to the I theta 2, we figured out that z times w is r1 times r2 e to the I theta 1 plus theta 2. Well, if this is in polar form, where's the r? Well, it's out here, it's just 1. Basically, these are on the unit circle. Can you tell me why they're on the unit circle? Well, what's the modulus? First, let's look at these numbers. What is this? Cosine of pi over 2 is 0. This number here is 0 plus I times 1, because sine pi over 2 is 1. So it's this times cosine of pi is negative 1, sine of pi is 0 plus 0. So this is the same as negative I, right, when we multiply this together. According to, and what is the modulus of this, incidentally? Well, what was the modulus of each of these individually? The modulus of I is just 1, because it's 0 squared plus 1 squared square root. The modulus of this is going to be negative 1 squared plus 0 squared square root is 1. So you could really have written these like this. Here's your R1, here's your R2. According to our formula, this should be equal to 1 times 1 e to the I, adding this together, pi over 2 plus pi. So this is e to the I 3 pi over 2.